Hi everyone, this is Miss Rapp and we are doing Algebra 2, Unit 5 Quadratics, Lesson 11, Quadratic Piecewise, pages 29 to 33. So get everything you need, let's get started. Okay, so the word piecewise should be familiar. We did it in absolute value. We are literally going to break our graph up into pieces. So let's start with the opener. Given the piecewise function g of x, evaluate g of -1 and g of 0. Okay, so this piecewise is split up. So it says g of x equals 3x squared plus 1 if x is less than 0. So if x is less than 0, I will use this formula, this equation, this expression. If x is greater than or equal to 0, I will use this linear, 5x minus 2. So visually, this is a quadratic and a linear. So g of -1, well, -1 fits into that category. So I'm going to say 3 times -1 squared plus 1. So I knew to use this equation because the input matches this rule. So piecewise have rules and you kind of have to work around them. So that's going to be 3 plus 1, which is 4. Because -1 is less than 0, I knew to use this. Okay, it says g of 0. Well, that's out. Oh, well, if x is greater than or equal to 0, I use this one. So this is going to be 5 times 0 minus 2, which equals -2. How did we know what function to use? The x value that satisfied the constraints. You guys know spelling's not my strong point. Okay, let's get started. So this says, using your knowledge of piecewise functions, graph the functions below. F of x equals 3x minus 2 if x is in between -2 or equal to 1. So that's what I'm looking at. So here's how you start this. You're going to find one point, and it's linear, so we'll use slope. So when x is at -2, the value is 3 times -2 minus 2, which is going to be, what is that, -8. So the point is -2, -8, but I'm going to do an open circle. And I'm going to do an open circle because that doesn't have a line under it. So now I'm going to go up 3 over 1, up 3 over 1. And I'm going to stop right here because it's only in between negative. So my x values are between -2 and +1. We got that. There's 1, 2, 3, 4 points total. This gets a closed circle because of that. And this is what the graph looks like. It doesn't extend further. Like, that's it. No arrows, nothing. There are no arrows because I'm constrained by my x values. Okay, let's try number 2. Number 2 needs an edit. This should be a +5. So let's get started. I'll start with the first one. 3x minus 2 if this. Oh, that's the same as this one. So I'm just going to take a moment and graph this over here again. So that was an open circle there. 1, 2, 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. So that's this one. That was just a duplicate. This is graphing 2 at once. So now for this one, I start at 1. So that would be 2 times 1 minus 8, which is -6. So then, right, this has a closed circle. So down here at -6, this will be open. I also know it's open because on this one, the 1 doesn't have a line. So see how these alternate, line, no line. And then I'm going to go up 2 over 1 until x equals 5. And there we have it, you guys. That is this graph. Okay, let's try number 3. Okay, this reminds me of absolute value because it's the same line, just with different slopes. So it seems like we're going to start at -2, -4. And this says -3 over 2. So that side is going down. This side is going up. So 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. So what you can do with this is you can see that they're the same linears and put them together, and you can say, oh, well, I know this is going to be y equals 3 over 2 x plus 2 minus 4. So I see that as well. Okay. This is a review from, I think absolute value is unit 4. We can break quadratic equations up into separate equations at its vertex. So just like absolute value. So let's graph the function provided. So this is going to be -1, -3 over 1, 1, 2, 3 over 1, 3 over 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. So step 1 is done. Identify the vertex, -1, -3. Create a function for the right side of the vertex. Well, the right side it's facing up on both sides. So the right side, so right here, that's going to be f of x equals 3, x plus 1 squared minus 3 if x is greater than or equal to -1. So this is what's important here, this part. And the left side is going to be the same deal, except for the constraint. Because I go, so it's not like absolute value where you have a negative side and a positive side, because that's not how quadratics work. They have like an a value and it's either up or down. So let's practice these. Step 1, let's just write the equation. So this is at, what is that, 6, 4? And the a value is 2. So we get y equals 2 x minus 6 squared plus 4. So when we break it up, it's going to be the same equation, but we're going to have these constraints. X is less than 6, and then we'll do the same thing. X is greater than 6. So with absolute value, this part wasn't really important, but now we want to really focus on this. So notice, same equation. I'm just breaking it up onto like the left side and the right side. Okay, let's try this one. This is at 1, 5. And the a value is, what is that? 1, 2, 3. A is -3. So I get y equals -3, x minus 1 squared plus 5. Let's break it up. And we'll break it up at the x value. Like notice, this is always the x value of the vertex. So I get -3 x minus 1 squared plus 5. X is less than 1. -3 x minus 1 squared plus 5. X is greater than 1. So just notice how they switch. This is a quick lesson, you guys. We're just breaking it up. This lesson is going to really help us with inverses. So make sure you feel good about this so you can do inverses. Don't forget to do your video check-in, rewatch this if you need to. Have a great day.